n is integer such that we can call this sign integer part, or someone says GIF, or floor of n squared over 3 is prime. Find the value of n. Okay. For solving this, let me at first explain for you that integer part is what? If it is, for example, 2.3, you say 2. You should see it is between what two numbers and round it to the smaller one. If you also say 2.9, again it is 2. If it is integer, for example, GIF of 3 is 3, GIF of negative 5 is negative 5, and the last one I should tell you, GIF of negative 2.4. You should see it is between what two numbers? It is between negative 3 and negative 2. It will be something like this. Round to the smaller number, it will be negative 3. Okay, so let's work on this. First, without loss of, let's check n0. For n0, you will see that it will be 0 over 3, which will be 0, and it's not prime. Because we have n squared here, without loss of generality, we can consider n is positive. And we've solved it, and then, for example, if, for example, n5 works, we can say 5 and negative 5 works. At the end, we consider plus minus of the numbers. So n is positive. So we want to use one important thing, one important idea that is useful also in IMO, the highest level of math exam, and I've solved some problems from that. If you want to know, you can comment or you can send message to my number, WhatsApp number in the description or comments to learn the idea. Small example. So here, we can say n1. n1 is what? 1 squared over 3, which will be 1 over 3. And it will be 0. It doesn't work. If we have n2, 2 squared over 3, which will be 4 over 3. And it will be 1. It's not good. It's not good. Let's check n2. It will be, I've checked n2 and 3. n3, we can say n squared. Now let me tell you, you can write this sign is equivalent to this sign. Both of them are same. N squared over 3 equal to 3 squared over 3, which will be 9 over 3. 3 integer part is good. So n3 is good. We found one answer. n4, if we check, it will be 4 squared over 3. 4 squared is 16. 16 over 3 will be 5 point something. Integer part of that is 5. It's good, so n4 works. So now let's consider n5. 5 squared over 3. It will be 25 over 3, which will be 8 point something, which is 8. It doesn't work. If we check, for example, n6, we will see 6 squared over 3, which will be 36 over 3. It's 12, it doesn't work. So we guess that maybe from here it doesn't work. But because we have over 3, n squared over 3, we should consider the remainder of n when divided by 3. That n is 3k or 3k plus 1 or 3k plus 2. And solve them and see, okay, which of them results a prime number. So let's check these 3 cases. Okay, case 1, I consider n equal to 3k, and I can say k is at least 3 because I've checked k to 6 here. So n squared over 3 is 3k squared over 3, which will be 9k squared over 3, which will be 3k squared, and integer part of that is 3k squared because it is integer. K is at least 3, so it's not prime. Now, let's check case 2. In case 2, n is 3k plus 1. Case 2, n equal to 3k plus 1. So here, 3k plus 1, we've checked for So k1 result 4. So k is at least 2 here. Now, you should calculate n squared. From the identity, you should memorize this identity. X plus y squared is x squared plus 2xy plus y squared. So n squared is 3k plus 1 squared, which will be 3k squared plus 2 times 3k times 1 plus 1 squared, which will be 3k squared is 9k squared, 2 times 3k is 6k plus 1. Now, if I consider n squared over 3, it will be 9k squared plus 6k plus 1 all over 3, which will be 3k squared plus 2k plus 1 over 3. If we consider integer part of that, n squared over 3 will be 3. This part will be cancelled. 3k squared plus 2k. And if you factor from k, it will be k times 3k plus 2. Because k is at least 2, this part is at least 2. Also, this part is at least 3 times 2, 6 plus 2, 8. So the product of two numbers that are greater than 1 is not a prime number. So let's consider last case number 3. The remainder is 2, n equal to 3k plus 2. Because we've checked up to 6, in this part 3k plus 2, k is 1. So here again, we can consider k is at least 2. N squared, if we use again this formula, is 3k plus 2 squared. And it will be 3k squared plus 2 times 3k times 2 plus 2 squared, which will be 9k squared plus 12k plus 4. And now, if we divide n squared over 3, will be, let me write 9k squared plus 12k plus 4 all over 3. It will be 3k squared plus 4k. You can write 4 as 3 plus 1. 3 over 3 is 1 plus 1 over 3. So if it consider integer part and integer part of n squared over 3 is 3k squared plus 4k plus 1. You can cancel, you can get rid of 1 over 3, you can ignore that. So you can factor it as 3k plus 1 times k plus 1. Okay, so because k is at least 2, this part is at least 3, and this part is at least 3 times 2, 6 plus 1, 7. So it is product of two numbers that are greater than 1. So again, it's not a prime number. So we've checked all three cases, and we understood that after n equals 6, we don't have any n that creates prime numbers. So n3 works, n4 works if I want to write all answers because I said that without lots of generality. N is positive because we have n squared, so this part. Our answers will be plus minus 3 and plus minus 4 works. Let me write the homework for you. Consider integer part of n cubed over 3 is prime and try to find an n is integer and try to find all n that this creates prime number. Comment your answers below this video. If you have other solutions again, you can comment right below this video. And if you want to learn important ideas about prime number theory and also other topics, algebra, geometry that are useful in math exams, you can send message my number, WhatsApp number in the comments and also in the description. Okay, thanks. See you next time. Bye.